Welcome to clickmeproject.com. Our project title is Transaction Briefs Computing Seeds for LFSR-Based Test Generation from Non-Test Cubes. Abstract. In test data compression method that are based on the use of a linear feedback shift registers, a seed that produces a test for a target fault is computed based on a test cube for the fault. With the given LFSR, a seed may not exist for a given test cube, even though a seed may exist for a different test cube that detects the same fault. This issue is addressed in this brief by computing seeds for LFSR-based test generation without using test cubes. Instead, the procedure described in this brief is based on the use of non-test cubes. A non-test cube for a default must be avoided in any test or test cube for the fault in order to allow the fault to be detected. Therefore, non-test cubes do not limit the ability of the procedure to compute seeds with the given LFSR. Experimental results demonstrate the advantages that the use of non-test cubes provides and the associated computational cost. Let us see the flow of our project. First, we have to split up our project in two sub-functions. First one is test control function and next one is RAM memory architecture. For that first one, we have to create LFSR generation, and this LFSR generation is used for creating the random pseudo numbers. Then we have to design one adder circuit, that is 8 cross 8-bit adder circuit that produce a 9-bit output result. This input produced two functions, that is A and B, that is given to the test process. We have to store that output values in we have to store our output in RAM memory architecture and then compare our output result with this RAM memory architecture. That is, we have to read our process and then compare. If the result is equal, we have to print that in faultless bit, else fault is occurred, so we have to identify that. Let us see the output of our project. Open the Silinks window, and when we complete the process, we open this window, there is output window. In this window we have to set clock for our process, then period is 1000 nanoseconds. First we have to reset our process. So when we release this reset button, our process will be started. So our process is to LFSR generation, and we have to create one 8-adder bit. So our process is stored in this memory. When we click on enable is 1, it is read from our memory. So our process is readed and it is compared with our output. So it's matched, so it produce 0, otherwise it produce 1. Then we have to let me see our synthesis report. This is our synthesis report. In this report we have calculate our area, time. This is our slice logic utilization, number of flip-flops, memory, RAM used by our project, and this is for time report. Then let me see our implementation result. First we're going to see our RTL diagram. This is our RTL diagram. This is our RTL diagram. Let me see our technological schematic diagram. This shows that number of flip-flops and the look ahead, that is lookup tables.